everyone, welcome to the PyCharm FastAPI tutorial series. In this tutorial, we will be deploying our application in AWS using the Elastic Kubernetes service, along with setting up a domain with SSL. Make sure before proceeding that you have installed the AWS command line application. There's one more application we need to install in our system, and that is EKSKTL, EKSCTL. It is the official command line tool for EKS, Elastic Kubernetes Service, and helps in managing clusters in EKS. It's developed by Weaveworks and written in Go. Make sure you have both kubectl and EKSKTL on your system, and also we expect from the audience that they have a previous working experience in AWS. I'm going to skip the installation steps as it has been clearly provided in the AWS and EKSKTL documentation. You can follow that easily, or there are tons of articles available on how to do that. Coming back to the AWS Management Console, I will create an administrative user from which we're going to access all of our AWS services. I generally don't recommend this approach when you're working in a production or sensitive environment. Kindly follow the principle of least privilege. As this is a tutorial, it doesn't recommend anyone to follow the same approach when working in a production environment. Make sure to properly authorize your access keys only based on requirements. I'll go to IAM and create a new user with full administrator access. I've already created the new user. I just need to create the access key. Now I need to set up these keys in my AWS CLI. I will open up my terminal and type AWS configure. After that, I will provide the access key, secret access key, and region name set to AP-South-1. We've successfully configured. Next, we will go to ECR, which is the Elastic Container Registry. We will push our Docker image to our ECR repository. I'm actually going to try to cover the use case when some people out there want to work with a private registry instead of using a public registry like Docker Hub. I'll create a repository and name it FastAPI-ecommerce. Visibility is going to be private. The repository is created. Let me push the Docker image to ECR. But before pushing, we need to communicate our credentials, and after that, we should be able to push the image to AWS. Once you open the repository, on the top right, you will see a link appearing, View Push Commands. I'm going to click on that. I will copy the first line and execute in the terminal. Login succeeded. Now build the image and then tag it and finally push it. The image has been successfully pushed. Let me verify in the console. Yes, the image is appearing now, and the total size is around 179 megabytes. Now I will create a private key PEM file, which will be used to get access inside of the EC2 machine. We won't be getting inside of any particular instance, as we will be handling everything through Kubernetes. But this can be used for many kinds of scenarios like debugging, checking something particular in the machine. I will open key pairs, which are going to appear in the EC2 dashboard under Network and Security. I will name the key pair as FastAPI-demo. I will come back to PyCharm and create a directory called EKS. I will create a new file and name it cluster.yml. We're going to create a 3-node cluster, and the good part is that the control plane is taken care of by AWS itself. I already have a working copy of it, so I'm going to copy and paste the code. Just for your information, EKS is not a free service. You pay 10 cents per hour for each Amazon EKS cluster that you create, even if you don't use it, and a separate cost of instances which are acting as nodes. Their costs are different based on instance types. These are expensive services. Make sure you have some credits before going ahead. Coming back to the code, you can ignore the yellow highlight which is coming up. This is because of the EKS kernel configuration, and the Kubernetes plugin is not able to identify it. Completely normal, nothing to worry about. Let me explain quickly what we're trying to do. We're going to create a Kubernetes cluster running the 1.21 version, and it will be deployed in AP-South-1 region. Next, we are creating the managed node group. With Amazon EKS managed node groups, you don't need to separately provision or register the Amazon EC2 instances that provide compute capacity to run your Kubernetes applications. You can create, automatically update, or terminate nodes for your cluster with a single operation. Applications stay available. You can go ahead and also create unmanaged node groups if you prefer that. We'll be creating 3 EC2 instances, and the instance types are going to be T3A.small. Also, we're allocating a GP3 volume type with a size of 20 gigabytes. Amazon EBS GP3 volumes are the latest generation of general-purpose SSD. Observe line number 16. Private networking is set to true. This basically means our nodes can't be accessed publicly, and all the EC2 instances will communicate over the private network. It's not only EC2, even if you can create spot instances or go serverless like Fargate. Next, observe line number 18. We're going to be using the attach policy ARNs. There are 4 policies which we have added to work smoothly with the cluster. If a node group includes the attach policy ARNs, it must also include the default node policies like Amazon EKS worker node policy, Amazon EKS under CNI under policy, and Amazon EC2 container registry read-only. Carefully observe line number 19, the SES EKS policy. This is not the default policy. Instead, it's a custom policy which we've created to grant permission to send email through SES. Hang tight, I will show you in a while. Your ARN number is going to be different, so make sure to replace that, otherwise cluster creation will fail. You can observe that we have provided SES access to send email. We're also using some add-on policies like auto-scaling, the image builder which allows for full ECR, Elastic Container Registry, access, along with Certificate Manager for managing SSL certificates, and ALB ingress referring to the application load balancer. And finally, SSH access to nodes is set to true in reference to the private key name FastAPI-demo which we created earlier. There are plenty more add-on policies which you can add based on your requirements. Do check the EKS Kittle official documentation. Let's now go ahead and create the cluster. Open up the terminal and move inside the EKS directory. I will type EKS Kittle create cluster -f cluster.yml auto-kubeconfig. Auto-kubeconfig is going to save the config file under the directory .kube/ekskittle/clusters. The file name will be set as the cluster name which you have provided. The cluster creation process will take somewhere around 15 to 20 minutes. The cluster has been successfully created. Now I'm going to copy the kubeconfig file FastAPI-demo to our EKS directory. Let me check the number of nodes by passing the kubeconfig FastAPI-demo. You can observe 3 nodes are running and the operating system is backed by Amazon Linux 2. The nodes are completely private. You can observe the internal IP and there is no external IP exposed. Next, we're going to approve the OIDC provider. To use IAM roles for service accounts, an IAM OIDC provider must exist for your cluster. User authentication for Amazon EKS clusters can also be performed from OpenID Connect OIDC Identity Provider IDP. This feature allows customers to integrate an OIDC identity provider with a new or existing Amazon EKS cluster using Kubernetes version 1.16 or later. The OIDC IDP can be used as an alternative to or along with AWS Identity and Access Management, IAM. I'm going to type ekskittle utils associate-iam-oidc-provider along with region and cluster name. The OIDC provider is successfully created. Next, we're going to create a security group for the Postgres database. This will be required when we'll be launching the RDS database. I'll go to VPC and then under Security, you will find Security Groups. I'm going to provide a name and a description. I'll choose the FastAPI-demo-cluster as my VPC, and this VPC is created by the EKS. Under Inbound Rules, I will select Postgres, which will be running on port 5432, and IP access will be set to anywhere. It doesn't matter because the cluster nodes are in private mode, so we won't be able to access the database publicly. Next, we will move to RDS, where we will be creating our subnet group. I'll be providing the VPC subnet private IP addresses from the 3 availability zones, AP-South 1A, 1B, and 1C. Our subnet group is created. Now we will go ahead and complete the process of creating a new database. The creation method is going to be standard create, and the engine will be Postgres, and the version which we're going to use is 10.17. The database instance identifier will be set to sampledb. The username is going to be Postgres, and I'll provide the master password. DB instances will be t2.micro. We need to be in control of our costs. Disable storage autoscaling. Under connectivity, choose the FastAPI-demo cluster, and automatically it has picked our custom RDS EKS database subnet group. Public access will be set to no. This is kind of an extra precaution. No one can access our database instance outside of our cluster. Next, I will be choosing the security group, which we created earlier. Under additional configuration, I'm going to provide the database name. Disable backup, performance insights, maintenance, and monitoring. As this is not a production setup, we can skip this. Everything looks good. I'm going to click on Create Database. It will take a few minutes to initialize our new database. We will come back to this later. Coming back to the PyCharm terminal, I'm going to create the role-based access control, RBAC, for our ingress controller. A role binding grants permissions within a specific namespace, whereas a cluster role binding grants that access cluster-wide. Kubernetes service accounts are Kubernetes resources created and managed using the Kubernetes API, meant to be used by in-cluster Kubernetes-created entities, such as pods, to authenticate to the Kubernetes API server or external services. Next, I will go to IAM and create an AWS load balancer policy. I already have the IAM policy file. You can take it directly from my repository placed under the EKS directory. I'll simply copy and paste the JSON. There's a warning coming up in the visual editor. I will remove ELB and add it again. As you can see, I am specifying resources to all resources, but it's prompting me as a best practice to define permissions for only specific resources. I completely agree to that point, as this is a tutorial and I'm not getting too strict, but please follow the concept of least privilege. Next, I'm going to create an IAM service account. You can associate an IAM role with a Kubernetes service account. This service account can then provide AWS permissions to the containers in any pod that uses that service account. I will copy the policy ARN and replace it. The IAM service account is created. Let me verify that. You can see one role has been successfully attached. You can check that this role is present under Roles in the IAM console. I will go ahead and create the ingress controller. An ingress controller is a specialized load balancer for Kubernetes and other containerized environments. It abstracts away the complexity of Kubernetes application traffic routing and provides a bridge between Kubernetes services and external ones. You can check out the website, which is coming up on your screen, for more information related to deployment, configuration, etc. This project was formerly known as AWS ALB Ingress Controller. We rebranded it to be AWS Load Balancer Controller. I will go ahead and apply the ingress controller. A copy of this controller file is placed in my repository. You can check for more references. The ingress controller has been created, but we need to update some config, which is basically the cluster name. I am directly going to live edit the deployment file. The default editor, which is picked, is Vim, but I'm using Nano, completely your choice. To use your favorite editor by default, set the environment variable kube_editor, all caps. You can even use Sublime Text, Notepad, etc. The controller is deployed in the kube system namespace. Under spec, I will provide the cluster name FastAPI demo. Save and exit. I will re-verify whether the controller is running or not. Looks fine. Next, after the controller, we need to tag our subnets for subnet discovery by the load balancer. You can view this link, which is coming up on your screen, for more information. I will tag all the subnets. The shared value allows more than one cluster to use the subnet. We're done with tagging. I will come back to RDS to check the status. The database is now available. I'm going to copy the endpoint. But before that, I will create a folder called Deploy under EKS. I'm going to create a new file and name it db-service. We're going to create an external name service. Services with type external name work as other regular services, but when you want to access that service name, instead of returning cluster IP of the service, it returns a CNAME record with a value that is mentioned in external name, which in this case is the RDS endpoint. I'll be doing the same operation for Redis as well. For Redis, we'll be using the ElastiCache service provided by AWS. The service name is going to be Redis service, and I'll come back and replace the external name. Let's go to ElastiCache and create our Redis instance. Same as usual, I will create a private subnet group for Redis, and after that, we will launch the instance. I'll choose the engine as Redis. Location will be Amazon Cloud. I'll choose the version 5.0.6. Make sure the node type is t2.micro. Elasticache is an expensive service. Be careful with that. I also need to create a custom security group for Redis. Set replicas to 1 and uncheck multi-AZ. Encryption, I'm leaving it as unchecked, completely your choice. Backups are not required for this tutorial. I will click on Create, and it's going to take some time to initialize. Okay, Redis is now available. I'll copy the endpoint and replace it in the external name service. I'll copy the other services which we've done earlier when working with Kubernetes locally, and there's no change in that. I need to replace the image URL, and this time we'll be pointing to the ECR container registry URL instead of Docker Hub. Next, I will update the secret. As you can see from line number 8 to 10, these are base 64 encoded values, and I've mentioned in the comment what we're actually passing. We are done with the celery part. Next, I will go for the job, which is basically the migration. There are no changes except the image URL. Now moving to code, same 3 files: deployment, secret, and service. These are encoded values that we're actually sending. The service file will be running on port 5000, and you can see this needs to be a node port, not cluster IP, because traffic reaching the ALB, application load balancer, is routed to node port for your service and then proxied to your pods. Next, we're going to create an ingress. This is something which we didn't do in our local system, but indeed we need it here. In Kubernetes, an ingress is an object that allows access to your Kubernetes services from outside the Kubernetes cluster, typically via HTTP or HTTPS. With ingress, you can easily set up rules for routing traffic without creating a bunch of load balancers or exposing each service on the node. From the point of view of a Kubernetes pod, ingress is incoming traffic to the pod, and egress is outgoing traffic from the pod. As you can observe from the file, carefully see the data being passed in the annotations. These are a few values that you must have definitely observed when you created an application load balancer ALB in AWS. We are doing some health checks and looking for a success response code of 200. The listening ports are 80 and 443. Observing line 18, we need to replace the certificate ARN, and for that we need to create a new certificate in AWS Certificate Manager. We're going to do it in a while. Under rules, we are performing two operations. One is the SSL redirection, which is being taken from the annotation as mentioned in line number 20. Next, we'll be sending the traffic to our e-commerce service, which is running on port 5000, which indeed points to the FastAPI backend. Just imagine in your head that Nginx is proxying requests internally to your backend service. This is what we're trying to achieve through the ingress. You can also perform path-based routing and redirect applications to different services based on the path. Let me now deploy the Kubernetes manifests except the ingress. I'll open up the terminal and move inside the EKS directory. Just to clarify, I've deployed these manifests in the default namespace. Completely up to you. If you want a separate namespace, you can go ahead with that. Celery and the backend are running fine, and we don't need to worry about Postgres and Redis as they are managed services by AWS. We're having enough resources. Let's try to run 6 replicas of our backend service. Six pods are running completely fine. Now let's run the migration job. Migration is completed. It was quite fast. We are not using the TTL seconds after finished. If we use that, then after a certain amount of seconds, the job will be automatically removed. Now, only one thing is remaining, and that is the ingress. But to move ahead with that, we need to make sure that we have a domain name set up in Route 53, along with an SSL certificate generated by the certificate manager. I'll now open Route 53. I'll click on Create Hosted Zone. I'll provide the domain name mukul.xyz. Make sure the hosted zone is a public hosted zone. I've already purchased this domain from Namecheap. You can purchase your domain from anywhere like GoDaddy, Namecheap, etc. And you can even purchase from AWS itself. Finally, I will click on Create. Zone has been successfully created. Now I'm going to update these records in our DNS settings, which are currently residing in Namecheap, because our domain is registered over there. Different registrars will have different settings. This is an example of how Namecheap settings look like. Previously, we were using the Namecheap basic DNS. Now we will update it with custom DNS and add records provided by AWS. Okay, the DNS records have been successfully applied. The effect might take around 48 to 72 hours. Sometimes the update takes place immediately within 10 minutes also. Fingers crossed this is something which is not under our control. Fast forwarding time, our hosted zone setup is now complete and the DNS has successfully applied the new records. Yay! Now we will go ahead and set up SSL in Certificate Manager. I'm going to provide the domain name along with the wildcard entry. I'll make sure to add these records in Route 53. The validation may take something around 30 minutes of time. Okay, as you can see, the certificate has been issued successfully. Now I'm going to copy the ARN and replace it in the ingress.yaml file. Observing line number 19, we are using the TLS 1.2 protocol. Next, I'm going to deploy the ingress. Ingress has been deployed. Let me check the status. Looks like there's some issue. We haven't tagged our subnets properly. Let me remove the ingress and tag my subnets properly. After that, I will redeploy the ingress again. Yes, I made a mistake. I need to replace the cluster name with FastAPI-demo. Okay, it's fixed now. Let me deploy again and check the logs. Yes, as you can see, it has been successfully reconciled. Let me quickly show you the load balancer address where ingress is pointing to. Next, I will go to Route 53 and create a new record pointing to our website. You don't need to do this manually. You can easily achieve this through external DNS provided by Kubernetes. We will create two records, A and C name records. The two records have been created successfully. The A record maps a name to one or more IP addresses when the IP is known and stable. Here we are pointing to the load balancer. The C name record maps a name to another name. It should only be used when there are no other records on that name. Let me now try to check whether the domain is pointing to the backend or not. And yes, finally, the domain is pointing to our FastAPI backend with SSL secured. I will quickly route to the docs section. Let me do a quick test. We've already done it multiple times on our local machine, but now it's live. Yes, our record has been created. Let me now try out the remaining APIs. Finally, we've successfully executed and listed our orders. So this is how we did the entire journey of application development, testing, and finally, end-to-end deploying the Kubernetes stack in AWS with fully qualified domain names and SSL. Let me check if I received any new order email. Okay, not yet. Nothing to worry about. Sometimes the email gets delayed because we're using a temporary email service. I recommend using a full-fledged email service like Gmail when you're trying out this application. There's one more thing which I haven't shown you. You can manage your EKS resources directly through PyCharm instead of doing it manually. I hope you've already played with the Kubernetes plugin or checked out my previous video. I'm just going to point to the kubeconfig file to FastAPI-demo, and then it works like a charm. And now you can see our pods, deployments, and jobs which are running. I hope you definitely liked the video and enjoyed this long journey from development to deployment. Do check my next video about reference materials, which I've used when I was working on this tutorial. I will share some good tutorials and blogs where you can go and enhance your skills more when working with FastAPI or EKS. Thank you, and I will see you in the next video.